Hi, if your tumble dryer has gradually got noisier, or it's making a screeching sound, or there's an acrid burning smell coming from it, and the drum is rotating slower than usual, it will probably be the motor. In this video I'll be replacing the motor and capacitor in a Hotpoint CTD Tumble condensing tumble dryer. The tools I'll need for this job are a Phillips screwdriver, powered or manual, a large flat bladed screwdriver, a pair of long nose pliers, a pair of engineer's pliers, although you may get away with just using the long nose pliers, a pair of grips, an 8mm socket and wrench attachment, and a multimeter. The first priority is to disconnect the mains power to the machine. Then remove the two screws from the rear of the top cover and push it backwards, then lift it off. This will allow you to get to the one screw on top of the side panel, which has to come out, as well as the four down the back edge. Once they've all been removed, slide the panel back a few inches and lift it off. The heater wires are attached via a plug assembly that will only fit together one way, so there's no need to worry about getting them crossed when it comes to reconnecting. Remove the bearing cover and all the screws around the heater cover, but not the two in the inside edge of the cover, because these are holding the heater on and it's not necessary to remove it for this particular job. Unhook all the wires from the impeller housing and using a large flat bladed screwdriver ease one of the joints out. When you have one out, it should be easy to lift the top up and over the impeller. The clip holding the impeller onto the motor shaft is in the centre and needs to be gripped with your pliers to release it. It can then be tapped from the back and it will come off. Don't try pulling it off, or you could damage the impeller fins, which would make it uneven and cause the new motor to vibrate, resulting in having to once again replace the motor. The motor has three wires. Two of them are attached to the capacitor and the third is connected separately. However, each one has a different terminal connection on the end. So before removing any wires, take a moment to look at the terminals. It's also a good idea to take a photo or make a diagram of them for later. One motor terminal attached to the capacitor has a saddle connector, and the other is just an ordinary spade connector, while the third wire has a sleeve terminal. The fan is held onto the other end of the motor shaft by another clip, but you'll need the long nose pliers to free this one. As with the impeller, don't try to lever the fan off via the fins or you'll damage them. Use your pliers and rest them against the cabinet, then place your large bladed screwdriver in between the fins and lever against the central sleeve section of it. Resting against the pliers will prevent you from damaging the inner rim of the fan. With the fan off, you have access to the four bolts holding the motor on. Use an 8mm socket and unscrew them. There's no special order in which they come off, but remove them from the enclosure when they're undone, or they may hamper you being able to turn the motor in the next stage of the removal. Use a pair of grips and twist the motor upwards to release the tension on the belt. You can then unhook it from the pulley. You'll need to twist the motor back towards yourself so it will clear the plastic moulding assembly before being able to remove it. The bearings on this motor are noisy, although it's still running free. However, this could change very quickly, and if they tighten up, it would put a strain on the windings, which would cause them to overheat and possibly burn out. Use an 8mm socket to undo the pulley assembly, and make a note which side the wires exit the motor before taking it off, so it will go back on the new one in the correct position, or they'll be on the wrong side when it's refitted. The pulley assembly has a lip on the inside which hooks into the casing of the motor. This helps to strengthen it and give it extra stability. On this particular motor, it'd be almost as easy to change the bearings as it is to replace it, but this video is on how to replace the motor, and we have another video on bearing changes. The thing to watch for on new motors is, although the screw holes are all there, they're not threaded. So to make life a little easier, cut the thread in all required holes before fitting the motor. The screws are self-tapping and you should be able to use just one screw to cut the thread in all the holes. Don't forget the lip on the tension pulley locates into the motor casing, so put that part in first before lining up the screws. If you've watched some of our other videos, you may have noticed that we undid the tension pulley to fit the belt, but in this case, because we have the motor out, we'll use that to put tension on the belt. The motor won't just slot straight back in place, it will need a bit of jiggling about to fit correctly. On the drum there'll be a mark around it where the belt previously fitted. Make sure it's lined up on this mark again before looping it over the drive shaft and feeding it onto the pulley. Use your grips with the jaws facing upwards and grip the screw between the two halves of the casing. Now lever down and this will twist the motor and put tension on the belt. It will also line the screw holes in the motor with the holes in the rear of the cabinet. You'll be very lucky if the holes line up straight away. In most cases it could take a bit of trial and error before you get them in line, but once you have one screw in, the rest are straightforward. Changing the capacitor is quite straightforward, but you may want to refer to your photo or diagram you took of the wiring earlier. Remove the two connections from the capacitor terminals and loosen the retaining screw. Remove the old capacitor and fit the new one. Remember to tighten the screw when it's fitted. Replace the wires on the terminals. Each terminal has two wires connected, one saddle or piggyback connector, and fitted to each of those is a wire with a spade connector. The sleeved connector fits a sheathed terminal in the wiring loom. When they're joined, put a cable tie around them to keep the wires together. The motor comes with a new impeller, so fit it rather than replace the original one, because that may have been damaged or twisted and could have been one of the reasons that the motor fault occurred. Push the impeller on the shaft as far as it will go, and then tap the inner sleeve with the tip of your pliers until the end of the shaft is level with the end of the sleeve. You may need to use a screwdriver to help getting the spring clip on. Replace the top section of the impeller housing and make sure all the catch segments are locked into place, or it might vibrate free as the machine's working. And fit the wiring loom in the channel along the top to keep it tidy and prevent it from rubbing on the side panel. The rear fairing will fit on quite easily, and if you tap it with the end of your pliers, as with the impeller, it will only go on as far as the end of the shaft. Finally, hold it in place with the spring clip. Remember to fit the cable plug through the hole in the cabinet before refitting the cover, or you'll have to take it off again. Replace all the screws around the cover. It doesn't really matter in which order they go back in, just as long as none of the heater wires are trapped. You may feel at the start of this repair that you could have left this small bearing cover in place because the heater cover will come out from under it, which is correct, but you'll have a job slotting it back under it when it comes to replacing it. As I said at the beginning of this video, there is only one way these two cable sections can fit together, so you won't get the wires crossed. Fit the side panel onto the base of the cabinet and slide it to the front of the machine. This will lock the bottom and front edges of the panel in place. The screws on the back and top edges hold it secured. It only remains to refit the top, screw it down, and the machine's ready for testing. Before you switch it on, just do an earth continuity test. Set your meter to the 200 scale and put one probe on the earth terminal of the plug and the other on any exposed part of the cabinet. If you get a reading, the earth's fine, but if not, the machine needs further investigation. On behalf of Selfix UK, we'd like to thank you for watching this video and hope you found it useful. Goodbye.